One of the challenging aspects of chemical reaction is predicting products. So let's try a predicting products problem. This one is predict the products of this reaction and balance it. FeO solid plus aluminum solid, and we have to figure out what they're going to form. Now, beginning off, we're going to have to decide what type of chemical reaction this is. Hopefully, we can identify that this is a single replacement. I have a metal ion, so this is a single replacement. I see that I have an ionic compound plus an element, and it's not one of the special combination reactions that we've had to memorize. So this is a single replacement. I see that the element, aluminum, is a metal. So if the element is a metal, it's going to be replacing the metal ion in the ionic compound. That means it's going to be replacing the iron. So we're talking about aluminum trying to replace iron as an ion. Note that, remember, with single replacement reactions, they only occur if the element is higher in activity than the ion it's replacing. So if we look at the activity series, we see that the only way this is going to happen is if the metal is higher on the list than whatever ion it's replacing. In this case, aluminum is the metal. It's replacing Fe ion, and aluminum on my activity series is indeed higher than iron, so I'm going to be able to do this replacement. Okay, so let's go back. All right, we have FeO plus Al. And again, the metal is going to be replacing the iron ion. So we're going to have a compound made of aluminum and oxygen. Now, I can't just copy over the same subscripts. Aluminum makes a different charge ion than iron does, so I'm going to have to calculate what this is. Aluminum makes a +3 ion. Oxygen will remain a -2 ion. When these combine using crisscross, it's going to have a formula of Al2O3. Now, the iron is going to become an element, and it will just be Fe. So I end up with FeO plus Al, Al2O3 plus Fe. Balancing it, I notice over here I have one iron, on the right I have one iron. I have one oxygen on the left, but on the right I have 3 oxygens. That means I'm going to have to go back and put a 3 in front of iron oxygen. So this is 3 irons on the left. That means on the right I'm going to need 3 irons. Going back on the left, I have 1 aluminum on the left and 2 on the right. I need to have 2 aluminums on the left. So now I think I have this all balanced. 3 irons on the left, 3 irons on the right, 3 oxygen on the left, 3 oxygen on the right, 2 aluminums on the left, 2 aluminums on the right, and this is my balanced single replacement reaction.